The dermis of the skin is where the innervation is. Recall that the epidermis is both avascular and not innervated. So it's pretty much all on the dermis to provide the nutrients and gases in blood, but it's also on the dermis to provide any type of sensation or control. Most nerves in the skin are for sensation or information incoming to the brain, sensory. When I say incoming, it means to the brain, because that's like the destination of all information. Free nerve endings in the skin are abundant, and these new nerve endings can sense temperature and pain mostly. These nerve endings they're kind of exactly what they sound like just blunt ends of a nerve. And I have two of them here, one in purple and one in yellow, and we'll just put the abbreviation free nerve ending, which we may use again in this class. Note how one of these, the purple one, is located more superficially than the other one. The purple one is kind of in a dermal papilla, and because of its placement, these two free nerve endings might sense different things. For example, the one in the dermal papilla might try to sense the temperature of the epidermal cells in an effort to understand the external environment's temperature. The yellow free nerve ending that's deeper in skin might sense pain from a puncture wound that has not only gone through the entire length of the epidermis, but has breached the dermis. So location determines function here. The other most abundant sensors in the dermis are collectively called mechanoreceptors, and they all have a funny-looking ending, like the rest of them do here. These are nerves with what are called encapsulated endings, or endings that are very specialized for a particular sensation. For example, there might be pressure centers located in the stratum basale of the epidermis and calibrated for very light touch. But pressure sensors located more deeply, such as nearer to the hypodermis, would be positioned to sense stronger sensations of pressure. Other mechanoreceptors called proprioceptors can also detect the positioning of the hands to determine the next movements. People who play instruments practice their instrument in an effort to coordinate these mechanoreceptors in their hands with their brains and play the music correctly. The word plexus just means network, just like the word reticular means network. We're going to see many capillary plexuses, which is a network of tiny little blood vessels. There's also little nerve plexuses, which is a network of nervous tissue, and we'll see those in this class too. So plexus is really like a general use word that just means network. It is always important for us to realize how a tissue or an organ is vascularized and innervated. How does it receive nutrients and how is it controlled? The dermis of skin has two networks or plexuses of blood vessels. There's the subpapillary plexus, which is the more superficial of the two plexuses. It runs just under the border of the epidermis and the dermis, and it has these loops that kind of go up into each of those dermal papillae, coming closer to that avascularized epidermis. So therefore, this plexus, the subpapillary plexus, is the one supplying, by way of diffusion, the alive, deep cells of the epidermis. As those epidermis cells get further and further away from this plexus, as they rise superficially, they die. So this plexus can be damaged in first-degree burns, and it is definitely damaged pretty much to nothing in second-degree burns. First and second-degree burns heal, And this is because this capillary plexus, although gone, there is another capillary plexus that is deeper, and it remains intact to supply oxygen, nutrients, and to fuel the repair of the burn. The deeper of the two plexuses is called the cutaneous plexus. This plexus lies along the border of the reticular layer of the dermis and the hypodermis, that adipose fat tissue that's down there. Remember that in some areas of your body, such as the tops of your feet and the backs of your hands, there's little or no hypodermis. Oxygen and nutrients from the cutaneous plexus, they diffuse superficially into the reticular layer of the dermis, and they supply the cells such as the fibroblasts and the macrophages that are kind of like running around the dermis. Notice how the subpapillary plexus, it is connected to the cutaneous plexus, right? There's vessels that go between them, and that the size of the artery in the red and the vein in the blue are just a tad bit larger than the vessels in the subpapillary plexus. Yes, this is true. This is because the subpapillary plexus, it's kind of like an extension of the cutaneous plexus. The blood in the subpapillary plexus comes from and is drained to the cutaneous plexus. The cutaneous plexus is not just damaged in a third-degree burn, but burned away. And this is also why third-degree burns are called full-thickness burns, as they burn all layers of skin. They also remove all viable blood vessels. Without oxygen and nutrients needed to repair the area, third-degree burn has little to no chance of healing. If you take a moment and think about this dermal circulation, and think about how crucial these two plexuses are to the cells and the tissue of the dermis and the epidermis. Without the circulation of blood in these capillaries of these two plexuses, the dermis wouldn't be a living layer of cells. It would be avascularized and dead, much like your hard candy shell, the epidermis. The hard, crunchy candy shell of many insects is somewhat analogous to our skin. I don't know if you know this, but insects, they don't have skin under their shell. Their shell is their skin. They just have a shell and then muscle. Wound healing in the skin is remarkably similar to wound healing in bone, which we discuss in a future chapter. As with any tissue, the first step of a wound is to stop the bleeding, a function that's called hemostasis. This requires that some fibrin precipitate out of the blood and form a blood clot to stop the bleeding. At the same time that hemostasis is happening, inflammation is beginning. And I know that we think that inflammation is a bad thing, but it's not. It is a very beneficial process, but it causes redness, heat, swelling, and pain, which alarms most people and causes them to seek out a course of prednisone, which might not be to your advantage. The causes of these signs and the very last symptom, pain, are from the immune cells coming to the area. The blood vessels near the wound, they dilate, and they allowed all these cells called neutrophils and macrophages to come to the area. And this causes swelling. The neutrophils, they kill any infectious invaders, and then the macrophages clean up the mess. And this is what causes the heat and redness. Pain, which is a symptom, not a sign, because signs can be seen by the medical provider. Symptoms are only reported by the patient. But pain results from the swollen area pressing on any free nerve endings, which then send sensations to the brain that there is pain. Up to this point, everything has been like like the response of EMTs or paramedics. Just stabilize the area, which means to ensure that it's clean and that there are no invaders present. Once the neutrophils and the macrophages are done cleansing the area, this is when fibroblasts start to come in. And these are cells that secrete fibers for connective tissues. So they secrete collagen, elastin, and reticular fibers. They can recreate the dermis. Not only will these cells start making those fibers, but they also proliferate or multiply. Take a look at the picture on the bottom left. This blood clot is now just a scab on the epidermis, and the dermal tissue below it has turned to what we call granulation tissue, which is a fancy name for early scar tissue. As the fibroblasts lower in number, official scar tissue forms in that area. And this scar tissue will be remodeled over and over again over the years of the wound. Eventually, the epidermis will turn over enough times to make the scar less evident.